So considering the top of the unit circle here, if I look at pi over 4 minus pi over 6, common denominator would be 12. So let's see, I would multiply top and bottom of this one by 2 and this one by 3. And so I get 12 as my denominator, 3 pi minus 2 pi is 1 pi. I now can figure out pi over 12. So I'm going to apply the sine and cosine formulas for the angle difference. So let's look at the cosine of pi over 4 minus pi over 6, because we know pi over 4 minus 6 is pi over 12. So this is going to give me a value for cosine of pi over 12 by looking at it as the difference of two angles. Then I use my formula, cosine of the first angle times cosine of the second angle. Since this is a difference, cosine gives me a sum here, sine of the first angle, sine of the second angle. And again, pi over 4 and pi over 6 are special. We should have all these results memorized. Cosine of pi over 4 is the square root of 2 over 2. Cosine of pi over 6 is the square root of 3 over 2. Sine of pi over 4 is the square root of 2 over 2. And sine of pi over 6 is 1/2. And then we can decide how we want to clean it up. I think I'm just going to leave this as a sum. Square root of 2 times square root of 3 is square root of 6. And that's over 4. And then square root of 2 times 1 is just square root of 2. Oops, over 4. So that would be one way to state it. Since they're both divided by 4, I could say it's the square root of 6 plus the square root of 2 all over 4. And I think I'm going to say that's my exact answer. So I don't have that memorized, but I know I can always find it if I need it, because I have the special angles pi over 6, pi over 4, pi over 3, and so on memorized. And so we have an exact answer for the cosine of pi over 12. And similarly, we can find an exact answer for the sine of pi over 12, because we have a formula for that. Sine of pi over 12 is going to be the cosine of pi over 4. Oh, not cosine. That was a strange slip up. Sine of pi over 4 minus pi over 6. So right, all I'm doing here is saying pi over 12 is pi over 4 minus pi over 6, and then I'm going to use the identity to come up with some exact values. So the sine formula starts off with a sine of the first angle, but then switches to cosine of the second angle. Sine gets the signs right. So if there's a minus here, there's a minus there. And then we switch cosine of the first angle, sine of the second angle. All right, so double check I wrote that right. Sine starts with a sine, but then switches to cosine. If this is a subtract, that's a subtract, and then it switches cosine, sine. Looks good. So let's see, sine of pi over 4 is the square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. And then we're going to have a minus square root of 2 over 2, 1/2. Cleaning that up like above, we're going to have 4 as the denominator. And then this time we get the square root of 6 minus the square root of 2. And think about it if that makes sense. If we think about this point right here for pi over 12, the x value is going to be much bigger than the y value. Notice the x value has a sum in the numerator, y value has a difference. So that fits that pattern there. So now I know the coordinates on the unit circle of the point where the angle is pi over 12. Now, counting by pi over 12 for a minute, 1 pi over 12 is here, 2 pi over 12 would be pi over 6. 3 pi over 12 reduces to pi over 4. 4 pi over 12 reduces to pi over 3. 5 pi over 12 is right in between here, and then 6 pi over 12 is at the top. So if I can find pi over 12 with my special angles, I should be able to find up here 5 pi over 12. So this angle at the top, let's redraw that. right up here is the angle of 5 pi over 12. And my claim is it's related to some of those special angles right there. We just got to figure out which two. And so if you think about the symmetry of the circle, the semicircle here, if that subtraction gave me 1 pi over 12, maybe the addition gives me 5 pi over 12. Let's check. So pi over 4 plus pi over 6. Common denominator would be 12 multiplied by 3 here and 2 there. And then 3 plus 2, yeah, there it is, 5 pi over 6, over 12, sorry. 2 times 6 is 12. So it turns out I could find sine or cosine of 5 pi over 12. So for example, let's consider cosine of 5 pi over 12. Because 5 pi over 12 is pi over 4 plus pi over 6. So instead of applying the angle difference formula up there, I would apply the angle sum formula. And so we can generate a whole bunch of other perfect, exact answers around the unit circle with these angle sum and angle difference formulas. So just like I can find pi over 12, I can find 5 pi over 12, I can mess around and I can get pi over 24. So anytime I can relate denominators like 2, 3, 4, 6, I can make related denominators, which is kind of neat. And so there's some homework problems you get to play with that. All right.